Okay, so the next question is a Ferris wheel problem. And when we have the Ferris wheel, it looks like the radius is 15 meters. Okay, the radius, if you think about it, is going to represent the amplitude, how far it goes up from the middle, how far it goes down from the middle. And it rotates once every 120 seconds. Passengers get on at the bottom, okay, and it's 1 meter from the ground. So if I draw a picture of this, okay, 1 meter from the ground, that would represent 1. It's going to go up and down, back to the bottom, and that takes 120 seconds. Okay, so that should represent my middle. The radius is 15, so it's going to go up to the middle, so the middle is going to be 16, and then 15 more meters to the top, so the top should be 30 meters. So think of a circle. The circle is going to be 30 meters big, and it's going to be, the bottom of it's going to be 1 meter off the ground. Okay, so if I were to just kind of sketch that Ferris wheel, there's the middle, okay, middle of the wheel, and then there's the Ferris wheel. It's going to rotate around like that. Okay, so what do I need? I need the cosine equation for this. Okay, so I need the amplitude, 15 meters. I need the middle, 16. I need my period, okay, my period from 0 to 120, okay, is my period. And then I need to, I'm going to use a negative cosine, so I'm going to use the 1 as my start. So my height as a function of time is equal to the amplitude or radius. I'm going to use a negative cosine graph. The period is 120, so I'm going to write it as 2 pi over 120. The horizontal shift is 0, so I'm going to start it at 0. And then my vertical shift is going to be my middle, 16. Okay. So the next question asks, what is the height at 45 seconds? Okay, so to do that, at 45 seconds, it's going to be approximately, that's going to be about 60 there. 45 seconds represents right about there. Okay, about 45 seconds there. Okay, so 30 seconds represents 1 quadrant. Okay, so that's going to be 90 degrees. 45 seconds represents halfway between there. Okay, so if I'm halfway between quadrant 1 and quadrant 2, I'm at 135 degrees essentially. Okay, so I should expect this to give me an exact value, although I could type it in my calculator, but we really could do this as exact value problem, and you may be asked to do this as exact value problem. So when I plug this in, I'm going to end up with this. 2 pi times 45 divided by 120 is 90 over 120, which is 3 pi over 4. Let me make that a little bit more clear. 3 pi over 4 plus 16. Well, 3 pi over 4 is going to be that 135 degrees there. It's going to be negative 1 over root 2. So I'm just going to plug that in. Negative 1 over root 2 plus 16. So the height works out to be 15 over root 2 plus 16. And that's approximately, when I type this into my calculator, is I'm getting about 70, oops, I'm getting 37 point, oh, that's not correct. .61 meters. Okay, that looks about right. 26.61 meters there. Okay, so the other question is, at what time are they 23 meters from the ground? So 23 meters, somewhere around there. It looks like there's 2 different times here. So I'm going to write my equation. 23 meters is equal to negative 15 cosine 2 pi over 120x plus 16. And I need to solve that equation. When I solve that equation, I end up with subtract 16 from both sides. I'm going to get 8. I'm going to divide by negative 15. And then I have to solve this equation for cosine. Okay. Now this is not a special angle, so I need to use my calculator. So I end up with the angle 2 pi over 120x theta 1. Okay, when I do inverse cosine or arc cosine of negative 8 over 15, I'm getting an angle of 2.133 radians. Okay, and then I'll solve for x here. I'll call that x1. When I solve for that, multiply by 120, divide by 2 pi. Okay, so I'm getting a time of 40.74 seconds. Okay, that looks about right. That's about 40 point. I'm going to write that 40.74. Okay. If I go down to here, I'm going to end up with the theta 2. To figure out theta 2, I have to use theta 2 for cosine. Okay, so that's going to be 2 pi minus theta 1. Okay, so I'm getting approximately 4.15. This is equal to about 4.15 radians. Solving for that x, I'm going to multiply by 120 and divide by 2 pi. Okay, so I get a time of about 79.326 seconds, which is symmetrical about that 60 seconds. Okay, so that's going to be 79.26 seconds. Okay, and again, notice that the symmetry across that 60-second middle coordinate, because those green dots are symmetrical about that point.